Fantastic. All right, so before we start, there were a lot of great questions that I had right before we took lunch. And one of them was observation here. What was your name? Akhilesh? I'm probably not saying that right, am I? Akhilesh? Okay, Akhilesh. Who observed when we went through, and we're kind of partway through this process right here. We're right at the crossroads, but kind of observed, for large, complex applications that we want to split up, especially even if they're distributed or not, the point is these are moving targets right here. And I completely forgot the name. The gentleman here said, I'm really bad with names, said, well, so once you do this, unfortunately, there's going to be quite a bit of governance needed, isn't it? Because this is not just a one-time process. In other words, in the spirit of your other question about this being iterative, sure, this may take you 4 months to actually do these refactorings in a large application. And so there's a very good point about that. But how can we govern all of these domains? Once we kind of carve out the dependencies and refactor, we still have additional functionality. Developers are still going to create mountains of package structures and stuff. And so how can we actually try to govern that? Part of it, part of the answer to share with you, was that we can actually write fitness functions, what Neil Ford talked about yesterday, or in his book, Creating Evolutionary Architectures, to write fitness functions that actually know the dependencies and to basically fail a unit test if we kind of cross a domain, for example. But there was another way to help govern these. There is another option here, especially if this is going to be longer term. You remember how we identified all these packages, and then we started to create domains. And from here, I did my refactoring from app.tracking, as you remember, to app.customer tracking. And so we're pretty good with customer right now. One of the options I have at this point is to take this functionality right here and actually move that to a separate project and create a jar file or a DLL with that. And so the point is now I can use Java 9 modularity, which is Jigsaw, or I can just use Jigsaw if I'm not already at Java 9. I can use Penrose, for example. If I'm in .NET, I can use Prism to be able to, or OSGI, but no one uses that anymore, to be able to manage those jar file dependencies. So think about that. You guys are the customer portion. Now, we still need to do domain scoping. We still need to build all of this. So visually, these are you guys right here. We've kind of already done the refactoring. We've flattened, and we have identified. These are all the customer packages right here. What I can do is I can take all of you as code, and I can just move all that code to another project and create it as a jar file that you guys now use. And that's exactly, so those dependencies between jar files is exactly what that list of tools I just described, Java 9 modularity, Jigsaw, Penrose, OSGI, Prism, all do is manage those dependencies, and that's where those frameworks would kick in. But there is a degree of modularity now, because now we know that it's going to be harder to cross this boundary, these stairs right here over to you guys. And so it is an opportunity at that point from a governance standpoint to start actually creating what's called a modular monolith. All right, so now, yep. Yeah, so let me repeat the question. And at this stage, whoops. Well, what happened there? Oh, that's right, I was moving to where we were at. Yes, absolutely, and let me redo the question. At this stage, where we're at right here, as you notice, we've done a lot of refactoring and such. And so the question was, well, shouldn't we here try to look for the dead classes and also, things that aren't being used much or at all, because that's going to be waste that we're going to actually be converting. And as a matter of fact, boy, that was a long time ago. Wednesday morning, my first talk at the conference. That was Wednesday. It seemed like it was last week. Wednesday was software architecture patterns. or anti-patterns, software architecture anti-patterns. And one of the patterns I introduced in that session was the lava flow anti-pattern. And what you're describing is the lava flow, where we have all this dead code everywhere. It could be dead classes, could be dead methods, and exactly, this is another place, because if we're going to be rewriting or migrating stuff, what better chance to do this now to reduce some of that waste? So yeah, this would be another great thing to do at this point. Absolutely. All right, so in our roadmap, we've got 3 steps. We took a break at lunch, and that was a great break because that wasn't too painful. Now, I can tell you, and I love this break because all the stuff we're going to look at now, up until the end of the class, is painful. This is really the hard stuff of microservices. When you walk out of here, the technology piece, in other words, not the technology, this is all technology, the coding piece is going to seem so easy compared to all this design stuff. You're going to be like, boy, I'm glad I'm coding now because this is easy. Coordinating all the tools, stuff like that. But the next step is to now start distributing our application. And that first step is to separate the user interface from our application. And when we lift or break apart the user interface layer, or if we have an unstructured, just those user interface classes, what we need to necessarily create is an API facade. You have 2 choices here. You can certainly create an API layer at this point. That would be choice number 1, because we know we're probably going to use an API. And so this might be the opportunity of actually adding that API interface there. Alternatively, though, that's an option, because we could have just a class right here in our service that exposes the RESTful endpoints. And as a matter of fact, sometimes you're at this point already of separating the user interface, in which case all the tour we just saw before lunch is exactly what you would do to this back-end part right here. But this would be a simple service locator pattern to be able to use usually REST to get to that functionality. Now, we do have a crossroads, though, because when we do split this apart, this is going to be a separately deployed unit, the user interface, whatever UI framework we happen to use, and this is all going to be our back-end code. Depending on your platform and implementation, if you want to use REST, unfortunately that back-end code is going to require a web server. And a lot of times all we have is a container. And so in that case, that would be the choice to say, should I use messaging or REST? I would use REST if I have a web server that I can deploy this, for example, EAR file or that assembly in. But if I don't, that's when I would choose to use messaging potentially, because then I don't need a web server in order to communicate. All right, so once we get to this point here, now we get to have some fun, because we take, whoops, let me turn that back on here. We take now those domains, and essentially what we're doing is, watch this, we take each domain, we take that code, and we do a refactor move over to a separately deployed unit of software. And this is what we saw as service-based architecture. And as a matter of fact, now it's all connected to the same database. And that's actually how a process to actually get to service-based. And as we remember, this is a stage where now we've got separately deployed units. These are just separate EAR files. They're separate projects. It's a refactor move over to another project in Eclipse or IDEA or Visual Studio, whichever we happen to be using. And so now I'm managing 4 different deployments right here. I've got customer, order, shipping, and payment services. This is not overly painful. Again, no organizational change, no DevOps, that sort of information. So this is a stage that we get to where now I talked in my keynote about that steeplechase. In other words, once we're here, now we start generating our DevOps infrastructure. And since most of you saw the keynote, we remembered that once we get to this point, which now we've seen the pathway, which isn't overly complex, now I get to analyze what portions of the application should be microservices. And now we've got some decision criteria. Which portions of this need higher levels of agility, the ability to respond quickly to changes, which translates to how volatile is the code here? It all points to the volatility. If our code doesn't change often, then we don't need a lot of agility. And so agility, testability, and deployability, that whole time to market, that competitive advantage thing I talked about at the keynote, whether we need scalability at this point, whether we need fault tolerance. But we get to ask that why question at this point about now what should we tackle. And that was the bottom line of the keynote of that section, which was not every portion of the application needs to be microservices. And so when we start splitting it up, this one is fine. It's a coarse-grained service. This one is fine, not this one. And so now we start splitting up only the portions that need to be split into further service decomposition. And again, it might impact based on scalability, fault tolerance, and that overall agility piece. And then at that point, then we start pulling the trigger on the database piece and move the database over. And so it really comes into two separate stages. Now, the interesting thing is here, this steeplechase part that I referenced in the keynote right there. Now we get to actually see the fact that that's not just one of these, let's define all the services and do this later. These have to be done at the exact same time. And so let's actually take a look at that. So now there was a, let me see, I wrote down, I was cutting, porting, performance in sync. There was a question here, and I can't look at it because I can't read my writing, about just identifying services. And, oh, Manoj, where are you? Oh, there you are. That's what it was. I didn't write it down, just in terms of a process of identifying services. And so that's where we're at now. So we kind of saw the process, but now we're going to actually dive a little bit deeper and actually see how do you identify a service. And as a matter of fact, this is where most of those pitfalls that you were referring to or asking about and anti-patterns actually occur. This is where most of the mistakes that I have seen in microservice happen. So we talked about the 3 tests for granularity, but we need services in order to ascertain whether we should expand them or contract them. So my friend Sam Newman, who wrote the Building Microservices book, kind of the first O'Reilly definitive guide to microservices, has this to say. He says, start out more coarse-grained and then move to more fine-grained as you learn more about the service. Extremely good advice. So when we define services, let me tell you, there's 3 ways of defining a service. The first way is this, a function-driven or a top-down approach. Let's take our application, start dividing out the functionality, and build services from it. And I can tell you firsthand from experience, that won't work. You won't get the right kind of services, and you will be constantly struggling all through the entire year after year after year of that project. It will be a lot of pain. It doesn't work. And so we realized it's all about the data. That's why we have problems. So another approach to service definitions is to forget about the function-driven and just do a bottom-up, a data-driven approach. In other words, take a look at the data and the groupings of data and those data domains and build services from that. And I can tell you, like the function-driven, it gets you a certain way there, and then we'll fail. You won't have the right kind of services. As a matter of fact, there's a third way, which is a request-driven approach. It's like, ignore the database, ignore functionality. Let's just focus on the nature of the request, the kind of requests we have. As a matter of fact, if you have a, quote, SOA architecture that you're kind of breaking apart, these, in fact, might be user requests or they might be existing SOAP requests that you have in an ESB. That will get you a certain way, and then we're going to hit a roadblock. None of these work. Well, if none of these work, then what does? All 3 done together. That's what works. And this is one of the biggest issues associated with starting to define services. And let me demonstrate. Here's the pathway that I use in order to identify a service. And this comes pretty close to getting it right the first time. The first thing we do, now notice the symbols. And as a matter of fact, I'm going to back up one slide. So I want you to pay attention to the symbols here. Function-driven is going to be the cogs. Data-driven is going to be the cylinder. And then request-driven is going to be this little glyph image right there, that little green person there. Okay, so the first thing we do to identify a service is we start, notice the cogs right here, we take a function-driven approach. and we identify coarse-grained areas of our application, chunks, portions of it. And from there, we identify those coarse-grained macroservices based on kind of Sam Newman's advice. Wait a minute, Mark. You just stood up here and said, that won't work. And it is correct. But it does get you to a certain point. Now, I've been on teams. I've been helping companies on teams that basically this is the only approach they do. They keep trying to divide out the functionality, and they start putting those services into production. And I say, well, what about the data? Nah, we'll do that later. And it never works. And so now at this point, but it's a good place to start. And this has been my experience, project after project after company. It's been my experience that when we started either greenfield or a conversion, is to start top down. It's just a good way of thinking about the overall functionality. But at this point, when we have coarse-grained candidates, now we do the bottom-up approach. And now what we do is we start mapping what data does this service candidate need that we just identified? What data does this one need? And notice this service right here on the left-hand side needs this group of data and that group of tables. Now this service needs this group of data and this group, but this service also needs that data as well in order to complete its functionality. Now, at this point, all I'm going to do is identify these crossovers, but I'm not going to do anything with it. Because the third step in this process, or I should say the fourth step in this process, is to now, notice that was a bottom-up, is to now combine the bottom-up and the top-down and refine the service granularity. Once I know the functionality right here, and I know the data that's used, what I'm looking for here are seams, S-E-A-M-S, seams, like in pants or a shirt or along the stage here. In other words, you see this functionality in this service. We were able to cut that functionality right in half. So this half used those group of tables. This half of the functionality used that group. In other words, there was a nice clear division, and look what I was able to do. Split that service up with its corresponding data. But not so much on the right-hand service. That right-hand service, there was no clear seam. In other words, the functionality was kind of curving like this, and kind of everybody needed the data. So that stays as it is, and I'm going to group all that together into one data domain. I still have this crossover right here. Now, what I do is I take a function-driven approach. So I go back to top-down, and every one of these crossovers right here become inter-service communication points. I can't talk to your data. That's the bounded context. And so take a look right here. What I've done is I've taken this crossover, and now I notice I have inter-service communication. Like I said before, is it okay that you have inter-service communication? The answer is yes. But as we saw this morning, it's pure evil. There will always and forever be evil in the world. There will always and forever be inter-service communication. But what we want to try to do is make the world a little bit better. And so we want to try to reduce that evil. The same thing here. So this is a point where I haven't written any code yet. And I can actually determine what kind of spaghetti mess I'm going to have on the back end. And I realize, Mark was right. There's way too much communication here. So now what I do is I go backwards and I refine the service granularity to start removing those coupling levels. I have not written one piece of code yet. So this is not, I'm not promoting big upfront design. This is iterative design of certain services that maybe match an epic or initial group of stories. But the point is, this is going to be a cycle that's going to repeat throughout the entire project. So now, the more functionality I start having, the more I have to continue for every iteration, this whole process of saying, whoops, we now have too much inter-service. Let's go back and refine the granularity and keep going back. Now, isn't it interesting that most teams, not so much, it used to be, most teams would not do this database mapping. We start to identify the functionality, the groupings, we get all that in production. It's like, yeah, let's talk about the data. And we start mapping the data, and it never matches our functionality. It's always this impedance mismatch. That's why it's necessary to do this top-down. Nowadays, a lot of teams say, yeah, we kind of got that. and we're there. And this is what we move into production with. And all of a sudden we find it won't work. We forgot one step, and that was the request-based. This last step, the sixth step here, ends up being almost one of the most important to actually validate our service candidates. Because what we have to pay attention to is the type of requests. We've done a great job, by the way. Now look at this bottom area here. We've done a fantastic job of identifying Service 1 and Service 2. You know, it's gone through all the way. It's got great groupings of data. You know, we have done it right. We've got data mapping functionality. We've reduced all this inter-service communication. This is perfect. Except we forgot about the kind of requests that are made to our system. So the point is, how many requests actually go to those individual Service 1 and Service 2? Or how many require coordination and orchestration between Service 1 and Service 2? And so here's what I use. I usually use a 90-10 rule, not an 80-20, but a 90-10. In other words, these services all have endpoints right here. What I have is an orchestrator service right here. And so now the point is this. If 90% of all the business requests that we have or are known go directly to Service 1 and Service 2 individually, then we're good. If only 10% require an orchestration, a communication between those two, 90-10, that's okay. I think we'll publish that. If it's the other way around, if only 10% of the requests actually go to individually to Service 1 and Service 2, and 90% require orchestration, then you know what I do? I go all the way back to step 4. And I refine the service granularity to make those services one so that I don't have to orchestrate them. Listen, 90% of the time I'm going to have inter-service communication. No reliability. I'm going to have fault-tolerant problems. I'm going to have performance problems. I'm going to have testability. These are coupled systems. These are coupled services. And then I determine the dependencies again because I've now changed the granularity. I go back and I check the requests, and I keep doing this loop. This process right here will get you pretty close to the right level of granularity in identifying your services. Oh, here we go.
Can you give an example of course-grained services created using function? Because I'm having a bit of trouble understanding the difference.
Oh, yeah, absolutely. So here's our application. Function-driven approach is to identify coarse-grained areas. In other words, this is our customer functionality. And you guys do tracking. And you guys do profile maintenance. These are coarse-grained areas. As a matter of fact, let's take it to an extreme. Hey, I like this better. Let's take your example, let's take this example and take it to an extreme. How's this? You guys are customer functionality. I'm going to make you a service candidate. Well, Mark, we're doing microservices. Micro means small. I know, and we'll probably get there. You guys are going to be customer, so I'm going to create a customer service. You guys are order management. Oh, look at how big this service is, everybody. But I'm going to create it as a candidate. Now, maybe this is a little too coarse-grained, and this would be shipping and warehousing. So now I say shipping and warehousing. Well, let's divide you up into shipping and warehouse fulfillment. You know, pick, pack, pull. Oh, I'm too tired to remember that. There's the 3 Ps of shipping. So I do the pick, pack, and package. Anyways, I fulfill the order and I ship the order, and so I split you guys into 2. That's an example of this first part right up here, of identifying those coarse-grained areas. Now, those services are pretty coarse-grained. Now, let's say packing for order fulfillment, and then we ship. What database, what tables are associated with those 2? And so this is an example. And so probably coarse-grained customer, I'm going to divide it up. Well, what do we do with customers? You know, we have to notify them. We have to change their information. There's comments. There's wish lists. And these would be certain areas, coarse-grained. Yeah. So those would be examples, of that. But yeah, that's what I mean about the top-down. You know, what does our application do? And you know what's really cool, everyone? The cool thing about this is I don't need, especially on greenfield applications, I don't need actually a whole lot of user stories yet to be able to define my candidate services. It really becomes kind of a factor of, well, what does this application do? I know we have certain entities, I know we have certain workflows. I don't know them exactly in detail, but at least the service becomes then a bucket to add functionality to. Yeah, so that'd be a good example.
So in this slide, in the fifth step, we have this inter-service dependency. How are we removing it? Because in the last step also, I see that dependency.
Oh, yeah. So in this case, good observation. Here, I didn't remove it, did I? No. All I said was, if I need your data, that translates to an inter-service call. In this case, notice, it's a good observation. You have good eyes. I never removed that. That's fine. Again, it's okay to have some inter-service communication. But suppose that these two services communicated with one another. And then this service communicated with this one.
Mark, can you point on that?
Oh, I'm sorry. Yes, this one. Suppose that this service needed this data here as well, so that I have inter-service communication between this service and this middle service, and then this service needed to talk to the first one here. That's all this chaining. In that case, I probably would have either consolidated these two or consolidated these two. Yeah. So
the best way to remove the inter service dependency is to break the layers and merge it into another service.
Yep, precisely. Yes, actually, that's one way.
Okay.
When we get to data, is it 2 o'clock? When we get to data, I'm going to show you a second way to remove that inter-service. It is not the only way to remove that. As a matter of fact, yeah, I love when questions are in context. Because we're on this topic, yeah, that's the end of that flow. Let's actually see what the other way would be, because I like this way. This is why I love this interaction. It's just so perfect. Because now, let me get back to where we were. So, there it is. There's the circle. Whoops, too much. How do I eliminate or reduce? I can't eliminate. How do I reduce inter-service communication? 2 ways to do it. The first way is service consolidation, combining services together. Okay. The second way, though, let me show you the second technique, just in case we run a little late and don't get to this part. Let me show you the second way to do it. And it's something called data domains. So let me show you. And we'll probably come back and revisit this slide. So here is a good example of what you're actually talking about, isn't it? Look at all this inter-service communication right over here between these first 3 services right here. And this communication here, and this communication. Well, these 3 services right here, these would be customer services, all are inter-service communication because I need the data here, the name, maybe a zip code, a mail code, or whatever. And so the point is this. Notice that these 3 pieces of information right here are all kind of shared. So watch what I can do. As a matter of fact, these 3 pieces of information are shared. These 2 services at the far right are communicating because they need each other's data just a little bit. Another way is watch this. Watch the animation. Are you ready? Set, go. Look at that. I've removed some of the inter-service communication, specifically the first 3 services here, by being able to share that small data context. And that is another way of removing it. It's called data domains. As a matter of fact, this is pragmatic microservices. When I get to the data piece, this is what we're going to see how to do. And so does every single solitary, so all of you are services, does every single solitary one of you need your own schema? The bounded context would say, yes, absolutely. The real world, to actually implement this stuff, would say, no, that's entirely ridiculous. It's not feasible. It's not pragmatic.
Mark, I have a question. Yeah.
Oh,
here.
yes.
Is it a bad practice that what we can do is each service have their own database, but for referential integrity, we will just copy over the foreign key values as in text into the other databases. So we don't need to do any sort of inter-service communications and can directly query on service database. So what I'm saying is customer a customer copy, a database table copy we will create under the payment information. So if someone want to see the payments, they don't need to get the name from customer service, because what I'm doing is I'm firing a command, and when any payment or get successful, I'm keeping a copy of customer name in payment database as a table name. So what I need to do is it will prevent my REST call or any inter-service call. That way that is also a way to do it. Is it a bad practice?
It is. Let me show you a variant of that, and then let me explain how to take that from a bad practice into a not so bad practice. But here's the context. So let me rephrase your question just a little bit. So here's the point. Let's reduce this to 4 services right here, and let me name these services. So this is going to be our profile, our demographic service for customer. And by the way, its database has an ID, name, and address, and stuff like that. Okay. The next service right here is going to be our wish list service. And this service has the customer ID along with the item and the expiry. This next service in the chain is our preferences service. And this preferences service right here, and its data has the ID and the preferences, maybe name value pairs or whatever. And finally, we've got a 4th service here that's our customer comments. And that has the customer ID, because that's the reference point. We all need customer ID, the date, and the actual comment. Well, here's the problem, and this is kind of what you're sort of describing, but this is in our context exactly right now of what we're talking about. And I apologize for jumping around, because this is usually a very nice narrative arc, but given that the question's asked, I love to address it right exactly, since we're in this spot about we've got this inter-service communication, how do we reduce it? Well, every request to the wish list, the preferences, and the comments needs the name of the customer. I only have the ID. Who has the name? The demographics. There are only 2 options available. I can go and get it through a RESTful call. Yeah, that's not very good easy, is it? It's easy, but I'm going to impact performance because of the latency. Scalability, testability, deployability, fault tolerance, reliability is all going to go down the tubes. Yes. So even by this point, hopefully we've realized the immediate reaction that you're going to have in microservices every time you need somebody's data, I feel like I'm dancing now, is to go get it, go ask for it. It is the natural tendency. Don't do it. Try to minimize that. Well, demographics has the name. I need it. Well, if I can't ask you for it, the only other solution is to replicate that data in my schemas. Is that what you're referring to?
Yes, that's what I'm saying. We can keep a customer name in every
Yeah.
services.
Beautiful. So, what do you think of this solution right here? Look what I've done, by the way. Watch this. If I replicate that name in every schema, watch what happens. I remove inter-service communication. Yes, so now we have a 3rd way of reducing that inter-service communication, don't we? We do. However, what have I done? You bet I have. Data inconsistency problems everywhere. Wait a minute, no one changes the name.
Yeah.
Who owns the name, by the way? Because all of you have it. Who really does own it? And how am I going to communicate and coordinate all of you from a transactionality standpoint when I go to update it? I never can. So yeah, this is the problem associated with this. However, this is a binary, a 0 or 1. Either I ask you for it or I replicate it as you're suggesting.